Fillmore Body Image Gym is more than just a fitness center. It is a cornerstone of community and wellness in the town of Fillmore. While it offers everything you might expect from gym, weights, cardio equipment, and fitness classes, what sets it apart is its commitment to fostering a supportive environment. This gym is a space where individuals can not only work on their personal fitness goals, but also connect with others, build confidence, and maintain a healthy lifestyle. Fillmore Body Image Gym creates a sense of belonging and promotes physical, mental, and emotional health. By cultivating a welcoming and positive atmosphere, the gym supports its members in managing challenges like weight loss, stress, and overall health improvement, tying its mission directly to the science behind cortisol, a key hormone that plays a critical role in both stress and metabolism. Let's start with what is cortisol. Cortisol is a vital hormone that often goes by the nickname stress hormone, though its functions go far beyond stress. It's a stress hormone produced in the adrenal cortex, the outer layer of the adrenal glands, which is on top of the kidneys. The molecular formula of cortisol is C21H30 and O5, a structure that includes three six-membered rings and one five-membered ring, making it a classic steroid hormone. This hormone is essential for a variety of physiological processes, most notably the body's response to stress. When the body encounters physical or emotional stress, cortisol is released into the bloodstream to help maintain energy by raising glucose levels, breaking down fats and proteins, and suppressing inflammation. Beyond stress, cortisol plays a crucial role in regulating metabolism, immune response, and even the sleep-wake cycle. However, while cortisol is essential for survival, imbalances in production, whether excessive or insufficient, can disrupt the body's delicate systems and lead to health complications. Let's move on to the role of cortisol. Cortisol plays a vital role in regulating how the body uses carbohydrates, fats, and proteins to generate energy, especially when undergoing stress. For fats, cortisol breaks down triglycerides into fatty acids and glycerol. Fatty acids are long chains of carbon and hydrogen that provide energy, while glycerol is a three-carbon molecule, which is converted into glucose in the liver. For proteins, cortisol breaks them down into amino acids, which are the essential building blocks of the body, and these amino acids are converted into glucose to maintain energy levels during stress. While these processes are necessary in the short term, prolonged cortisol elevation can lead to muscle loss, fat accumulation, and high blood sugar, highlighting the importance of balanced cortisol levels. Now, the biosynthesis pathway. The biosynthesis pathway of cortisol is a highly regulated multi-step process that takes place in the adrenal cortex. It begins with cholesterol, a lipid molecule that serves as a precursor for all steroid hormones. Cholesterol is transported into the mitochondria of adrenal cells where the first critical reaction occurs. This reaction is catalyzed by an enzyme called or cholesterol side chain cleavage enzyme, or P450SCC, which converts cholesterol into pregnenolone. Pregnenolone serves as the starting molecule for glucocorticoids, including cortisol. Once formed, pregnenolone moves from the mitochondria to the smooth endoplasmic reticulum, where it undergoes a series of enzymatic transformations. The next key step involves the enzyme 17A hydroxylase, which hydrates pregnenolone to produce 17-hydroxypregnenolone, an intermediate necessary for cortisol synthesis. This compound is then acted upon by 21-hydroxylase, which adds a hydroxyl group to form 11-deoxycortisol. The final step in the pathway takes place in the back of the mitochondria, where 11-B hydroxylase converts 11-deoxycortisol into cortisol. This process is tightly regulated by signals from the hypothalamus and pituitary glands, particularly during times of stress. The hypothalamus releases corticotropin releasing hormone, or CRH, which stimulates the pituitary glands to release adrenocortic hormone, or ACTH. ACTH then signals the adrenal glands to increase cortisol production. Once synthesized, the cortisol is released into the bloodstream where it binds to receptors in various tissues, influencing processes like glucose metabolism, inflammation control, and stress response. Now, for the image in the middle. The central image on the poster serves as a detailed visualization of the cortisol biosynthesis pathway. It begins with cholesterol at the top of the pathway, showing how it undergoes sequential enzymatic reactions to eventually produce cortisol. Each step highlights the enzymes involved, such as P450SCC, 17A hydroxylase, and 21 hydroxylase, emphasizing their specific roles into modifying the molecular structure of cholesterol. The image also illustrates the movement of intermediates between the mitochondria and smooth endoplasmic reticulum, underscoring the complexity and compartmentalization of the process. This diagram is crucial for understanding the intricacies of cortisol production and the importance of each enzyme in ensuring the hormone is synthesized efficiently in response to the body's needs. Now you may be thinking, how does this affect weight loss? Or how does weight loss affect cortisol? Weight loss affects cortisol levels in distinct ways for men and women, largely due to differences in fat storage and hormonal regulation. In men, fat tends to accumulate primarily in the abdomen, and weight loss often triggers a sharp cortisol spike, followed by a relatively quick recovery. This rapid response supports the breakdown of fat stores but can lead to temporary increase in inflammation if cortisol levels remain elevated for too long. In women, fat is more commonly stored in the hips and thighs, a pattern influenced by the hormone called estrogen. During weight loss, women are more likely to experience prolonged cortisol elevation, which can slow the process and make it more challenging to shed fat. This prolonged elevation can increase the risk of chronic inflammation, highlighting the need for tailored strategies to address these differences in managing cortisol effectively. So, what are the benefits and downsides of having elevated cortisol? Cortisol's effects on the bodies can both be beneficial and detrimental, depending on whether its levels are properly regulated. On the positive side, cortisol increases blood glucose levels, providing a reliable source of energy during stress or physical activity. It suppresses inflammation in the short term, helping the body cope with intermediate changes like injury or infection. However, prolonged or chronically elevated cortisol levels can lead to significant downsides. These include impaired immune function, increased fat storage in the abdomen, muscle breakdown, and mental health challenges such as anxiety and depression. Understanding this duality is critical for developing strategies to optimize cortisol levels and mitigate its effects while leveraging its benefits. Now, how can we manage our cortisol levels? Managing cortisol levels is essential for overall health, particularly during weight loss and stressful periods. To avoid the negative effects of cortisol spikes, gradual caloric reduction is recommended, as crash diets can often lead to sharp increases in cortisol productions. Regular exercise, including a combination of resistance training and cardiovascular workouts, helps regulate cortisol while improving overall fitness. Stress management techniques such as mindfulness and relaxation exercises, as well as maintaining adequate sleep, are also crucial for maintaining cortisol levels in check. These strategies are especially important for individuals seeking balanced weight loss with stress management and long-term health. In conclusion, understanding cortisol's role in the body allows us to make more informed decisions about fitness, health, and stress management. At Fillmore's Body Image Gym, members are empowered to manage their cortisol levels effectively through supportive programs, targeted exercises, and community engagement. For women, particular attention must be paid to managing prolonged cortisol levels and addressing the fat storage patterns influenced by estrogen. Men can benefit by incorporating strength training to maintain muscle mass and counteract cortisol's effects. Ultimately, Fillmore's Body Imaging creates a holistic and supportive environment where members can optimize their health strategies on their unique needs, ensuring long-term physical and mental well-being.